Hello, everyone, and welcome to the Cloud 101 Marathon. So we are, as you know, we kicked off 1 hour ago with Lisa, and now we are kicking off our stream on Twitter. And with us, we have special guests and speaker that will explain you everything you need to know about how to protect your machine learning workloads. Before I introduce the speaker to you, I also want to explain to you that we are going to share during our sessions, we are going to share an attendance registration link that you can use to basically confirm your attendance to the session. And consequently, you have chances to win amazing prizes, including Microsoft Swag Kits and C# Corner Swag Kits. So without further ado, I'm going to just welcome our speaker. Hello, Stefano.
Hello there. Hi.
How are you doing?
Good, good. Thank you. All good.
So, first of all, of course, thank you so much for being on board with us and contributing to this initiative. I can you let us know where you are based on?
I'm based in Melbourne, Australia, and
Okay,
work at Microsoft. And it's a great opportunity to share a bit of the work that we do in terms of protecting data, especially financial data, using the confidential cloud, as I'm going to explain in a moment.
okay, great. So, can you please share your screen, and then if you are happy, I can hand over to you.
Absolutely. So I'm gonna start now and share my screen, and hopefully you can see a
Yes,
slide.
yes. So I'm going to just activate your screen, and the stage is all yours.
All right. Thanks, Hugo,
We
and
wish you a great
welcome
session.
everybody.
Thank you.
Yes, so welcome everybody. I want to keep this session very not fluid, and ask allow for questions to be asked anytime. So feel free to type in the chat in the Q&A session, so I can take questions as we go. I have a few topics to cover, so I will pause after each topic and see if there are any questions to address. First of all, I'll cover a couple of topics that are specific to financial machine learning. As you see, online payment fraud detection and credit risk prediction. And then I'll go more in detail what is confidential computing, how it can help protecting this data that has been shared with machine learning services to protect these financial algorithm. And then I'll mention at the end on federated learning, which is an innovative approach to do machine learning in a decentralized way to protect your data and sharing a trained model, also in confidentiality. So, with no further hesitation, let's go into the first use case, online payment fraud detection. We have several credit card transactions, and I want to identify whether a transaction is a genuine transaction or a potential fraudulent. And I do this with machine learning. But let me ask you one quick question first of all. We have about 50 transactions here on screen. Can you see what's wrong with one of them? And it takes just a few seconds, and I'm pretty sure that you can identify there is something there that is not quite right. You see, this is all the same person, Mike Randall, and suddenly on 19th of April, he spent 2,000 euros in Kazakhstan. That's something different from what you and tip 200 euros or something, right? So there is a little anomaly in there. There is something that is not quite right. Now, how about this? Here we have different people. They're all buying from Amazon. Again, they look like they're all based in Ireland, but suddenly there is something again quite not right. And it takes a few seconds again to scan through the list to identify that there is another anomaly in there. And it's not just about the country or the amount, because you see 74 euros is not too bad. I mean, it's not too high anyway. but is something happening on the same day, 22nd of April. Johnny McTick is buying something for Amazon in Ireland and in Nigeria in the same day. So unless he took a flight from Dublin to Laos in Nigeria on the same day, it's quite unlikely that that could happen. So that is what we call an anomaly. And the purpose of machine learning is to help identify these anomalies as fast as possible. Now, this was pretty fast because you see, there are about 50 transactions on one side, 50 on the other side. It didn't take too long to scan all of these and identify the anomaly in this list. But just to give you some reference, only Visa, the credit card, handles over 2,000 transactions per second. That is more than 170 million transactions per day. Now, good luck opening an Excel spreadsheet with 170 million rows and finding the anomaly in there, right? And just to give you an idea of how important it is for credit card provider, for banks to either identify these anomalies. A report of 2 years ago, 2019, has estimated that fraud in the global economy, so online payment fraud, account for over 5 trillion US dollars. That's a huge amount of money. So we want to do something about it. And the problem is that still nowadays, many institutes are still using traditional analysis for identifying anomalies in online payments. And they use a combination of data, horizon scanning, which is what we did before. We were just scanning all the transactions. And sometimes they use a gut feelings when there are some security experts that create some risk tables, assign a score. They need to update this risk table and the score regularly and say, hey, all the transactions that happen typically in that country or in their region or in that time, they are suspicious because they have the experience, they've seen some data breaches happening, so they know what's going on, and they typically keep an eye on this sort of transactions. They may be biased, for sure they are, and they can report a lot of false positive as well. So it is a risk, but it's still happening a lot. So with machine learning, instead, we want to make this better, and we want to scale this also. So we don't depend on a security expert in a bank that have that go through all the transactions. And now, don't get me wrong, I'm not saying that there are people that actually scan all the transactions one by one. There are some algorithm that apply some rules, but these are static rules. They don't learn over time, and they rely on these risk tables that have to be maintained regularly. Instead, with a machine learning approach, there are two benefits. First of all, starting from the bottom, these models self-learn over time. So it means that these risk tables are maintained automatically, and they don't require anyone to update the score, the risk score, to make the prediction more accurate. And at the same time, it is a possibility that a smaller institutes that don't have access to large amount of data or to the risk table or to this security expert can still benefit of sharing data. But we want to share data in a confidential way without leaking any customer data, any confidential information. And this is what we're going to see in a moment. So just to complete on this anomaly detection thing, anomaly detection is done in machine learning, and it typically compares different measures. In this case, I'm comparing the average purchases per week with the purchases in this week. They cluster together, and if there is something outside, significantly outside of this cluster, then that is a potential fraud, is an anomaly. In machine learning, we can build up all these different variables, which we call features, by engineering or aggregating values depending on different conditions. As we said, as I mentioned before, number of transactions per day, per week, per month. If you typically do 1, 2, 3 transactions per week, and suddenly there are 100 transactions in that week, well, something's going on. Are you going on a spending spree? And it's fair enough, you may be doing, or someone stole your credit card. Risk tables, as I mentioned, group by country, IP address, and mismatch values, someone that buys in one country and billing in shipping in another one, and so on. Now, this is anomaly detection, as I mentioned, is used as a practice of machine learning for doing a lot of things, not just online payment anomaly identification, and it is done with two flavors. And now I want to mention specifically the Azure machine learning, so the machine learning capability that is available in the Azure cloud. One approach is unsupervised learning. Well, basically, we don't know what are all the different variables that contribute to make a payment anomaly or not. So we ask the machine learning algorithm to find out in all the number of transactions what contribute to make a transaction genuine or fraudulent. This is the approach of a PCA, or a principal component analysis. So the unsupervised learning doesn't know where to look, but it will find the principal components that determine the anomalies. Instead, if we know really well our data set and we label it, we can go for a supervised learning. In that case, we take an approach which is called one class support vector machine. And the name one class depends on classifying your transaction to be that one class or not. So it's fraudulent or not. Now, this is done in machine learning in a different way. So let me go actually and show you this, how that looks like in Machine Learning Studio, which I'm going to open now. And then I should move this to the browser. So if you go to the address studio.azureml.net, you can access this completely for free. There is nothing to pay, even without an account. 8-hour trial, you practice, you play with it, and then after 8 hours, your environment is destroyed. Or for the incredible amount of $0 per month, so it's completely free of charge, just with a Microsoft account. So with your Outlook account, for example, you can sign in and have up to 10 gigabytes of storage that never expires. This is good enough for your development and testing. Once you want to go live with your service that you develop in machine learning, then there is a fee to pay. But I'm not here to sell you Azure Machine Learning. I'm here to show you how to use it. So you sign in, and we need an account to sign in, which I'm gonna take from, let me see which account I'm signing in at the moment, as I have a few. And indeed, I sign in with the wrong one. So let me try this one more time. Apologies, it'll be there in a moment. Here we go. Sign in with this other account where I store all my machine learning services, and the password is not correct. So let me try one more time. So let me get there soon. I should have prepared it before, right? But I'm gonna be there in a moment. So yeah, update. Here we go. That's better. All right then. So there are all my experiments in there. We are looking into online. Let me sort by name. Online payment fraud detection. Here we go. All right. So I always start with data, and if we have a look at the data set here, this data set contains all our friends buying from Amazon, different countries, different amounts. Okay. Then I'll apply some transformation. I split the data between what is going for training and what is going for the the testing part of it, of the scoring part of it. So you see the two connectors, and then I apply my anomaly detection in here. If I apply the anomaly detection, on the scoring here, I can see that there are some probabilities that have been scored. So this probability will indicate whether a transaction is genuine or fraudulent. Because these are all very, very small numbers, the score label is 0, which means that it's not a fraudulent transaction. But if the score probability is higher, then the score label will be 1, which indicates that there is a fraudulent transaction. I can test this. So I can publish this service that I built visually, no coding required at all, as a web service hosted in Azure as a serverless web service, as a REST API, which is here, online payment fraud detection, and just test. So I can say that's now me. I'm in Australia. I'm going to spend $200 today, and the date has to be expressed in this format. Today is the 13th, right? 13, like this. And give an OK. And as you can see at the bottom here, there is a 0.08% of probability, or that, 0.088% probability that my transaction is fraudulent. So 0, it is not. If I do something different, like Stefano in Australia, but now let me spend $10,000, okay? So let me go a little bit on the expensive side and keep everything else similar. We're gonna now have a huge number, 3.36, and now the label is 1. So this is a risk for a fraudulent transaction. And now, obviously, this is just testing through the UI, but you can automate this process by invoking this URL, which is an endpoint for a REST API, passing the authorization bearer in the HTTP request, a JSON body with the client, country, amount and created on, so exactly the 4 values that we have seen before, and then you get a response with the label and the probability, and then this will automate the process, and you decide what to do with this transaction. All right, any question on this anomaly detection? Let me see if there are any in the comment. Oh, no question for now. Excellent.
No questions, Stefano, so far. No.
Okay, beautiful. Thanks, Ugo, for confirming. Let's go into the second use case, credit risk prediction. And again, it's all machine learning again. It's all in Azure machine learning, as I will show you in a moment. And it is based on a catalog of payment that is open source. It's called the German credit card dataset, and it is available as an open source for downloading at this URL. So I actually want to do one quick thing and show you how that looks like, because this data, so if I open it in the browser one more time, where's my browser? Here we go. Let me go in here, put in the browser. So this data set contains different fields, and all these fields, as you will see in a moment, I will show you in a machine learning studio, they all been anonymized, and there is a reference table in here. Anonymizing a data set, not encrypting, anonymizing is a good practice for protecting the confidentiality of your customers. But let's go in order. This dataset contains 1,000 records. 700 are classified as low risk, 300 are classified as high risk, risk of credit risk, so that are not repaying the loan that they apply for in time. Okay, the approach that I've taken is based on a 2-class boosted decision tree, and it works as a decision tree. So basically, ask a question out of the different variables that are available in the data set and check, hey, depending on the age of the person that is applying for a loan, what's the likelihood? So what's the class? Is a high risk or low risk? And then the machine learning service identify what the parameter to apply is low higher than 30 years old, is lower than 40 years old, and so on. And then it looks into employment status, marital status, whether there is some other credit cards, and so on and so on and so on. So every question is a bubble in this decision tree, and then it branches according to the two classes, low risk, high risk, until you get to the final answer. So number one, hopefully you can see here in this tree, in the decision tree, number one, low risk, number two, high risk. Okay. Now, because sometimes it's very hard to understand or to anticipate which machine learning algorithm fits better for not the data set that you have, one best practice when building machine learning algorithm is to evaluate the performance of two different algorithms. And this process, called model evaluation, will identify which one is more accurate than the other one. Even data scientists will struggle sometime upfront just to understand, okay, this one is a decision tree, or is a forest, a jungle, or any other type of algorithm that you can use. So we just try a few of them and see which one works better. And this is what I'm going to do again in machine learning. So I'm going to go in here in my machine learning studio and pick the other experiment, which is the credit risk prediction. Now, this one looks slightly more complex because, first of all, the data set in here contains all the different columns and many more columns in here. You see, there are different columns. And as you can see, these columns are anonymized. First of all, column 1, 2, 3, 4. So I don't really know what it is, but that doesn't really matter. As a person, as a human, you don't really need sorry, let me rephrase. As a human, you will want to know the name of the columns, but as a machine algorithm, you don't need to know, because machine learning works on these numbers here, irrespective whether the column 1 is gender, column 2 is marital status, column 3 is something else, and so on. It doesn't really matter, right? Although, by looking up into the description of this data set, I can actually see what's happening. So, for example, if I go into the attribute 4, I can see that the value A40 means that they have a car. A41, they have a car but is used. So if I look back in here, 40, then I can see all these different values. But it doesn't really matter what is the value itself. It matters that there are different factors. And to make things simple, I apply some metadata transformation. So then I can see, here we go. I can see the actual labels, okay? So, and in this case, as a person, as a data scientist that is looking to this, I can make some comparison. Again, not needed from a machine learning perspective, but because I want to see what's going on, no? As a data scientist, then I can make a comparison, for example, between the duration and the credit amount. So I go in here and say, hey, compare the credit amount with the duration. And as you can see, there is a bit of a clustering here on lower credit amounts and less duration in month, which is normal, right? So you typically apply for smaller loans, like 2,000 euros, 4,000 euros, 6,000 euros, in a less duration, 10 months, 20 months, 30 months. And only the big ones, like 50,000 or 100,000 euros, that requires 5 years or more for repayment. The same can be done also with other parameters. For example, let's compare with age. Okay, so if we compare with age, and then you can see that typically there is a bit of a cluster here, which shows that younger people in their 20, 25, 30 borrow a smaller amount of money. And then there are a few other ones. You can see there is a little bit of distribution, and it can show the frequency of, of borrowing and so on. Anyway, all these things that I'm analyzing manually is automatically done by the trained model. But I don't know which algorithm to use. And indeed, machine learning studio has many of these classification algorithms that I can use. You see, I mentioned forest and jungle. There is a regression. There is a, a multi-class or a two classes. So there are different types. Now, what I know up front that this is a two class because is really low risk or high risk. A multi-class instead is if there are different type of classification. So I go for the two class, but I compare. So you see, I build two parallel branches for comparing them and eventually evaluate the result and see how they perform. And this one, to be honest, they perform very similar, and is then important to go and see the accuracy and the precision. So the score dataset, which is the one on the left, has a precision 0.5, and the other dataset on the right is actually very similar precision. There are just a few numbers that are changing. So these two actually perform very similarly, but sometimes you may have a different algorithm that perform really different, and then you get the one that has the highest accuracy and precision. Anyway, also this you can expose as credit risk prediction as a web service completely hosted in Azure, and then you can test. Now I'm not going to test it because there are so many variables to enter, or you can even download an Excel spreadsheet, and this Excel spreadsheet contains a plugin in Excel, and this plugin is able to connect completely secure way to this web service that you just published. Is opening on my other screen, so let me move it here. Okay, so this is the Excel spreadsheet that contains the Azure Machine Learning plugin or add-on, and this add-on will be able to generate the data. So use some sample data. Here we go. So take some sample data in here, and then it can generate some data in here. So we'll put this one in the column U1 and predict. I think that's the way it works. I haven't used Excel for a while, to be honest. So let me see if that is actually working, or otherwise we'll carry on. That's okay. Yes, I need to specify the range of data. But here we go. This, and now should be. Here we go. Now it's working. So it's calling the web service and it's doing some prediction. Here we go. Scored. So value 1, low risk, value 2, high risk. And then obviously you will add your own value here in another column, rerun and do the prediction. Now, this one is just, again, Excel for testing. You can do the same with a REST API call, a post to this URL, JSON file containing all these labels, and then you get in response a label and a probability. Label 1 and 2, probability the actual number. Okay, all right. So in case you're wondering, happy to share my details at the end, and if you want to have access to this algorithm, happy to share them. They are on GitHub, free to access, to download. I actually publish also on the Azure AI gallery, I think that's the name. But let me talk about confidential computing, and actually let me go and check if there are any questions before proceeding with the next topic. No questions for now. All right, beautiful. So all of these data sets that we have been sharing, they contain some sensitive information. Although they've been anonymized, still there is information that can be used to identify specific individuals. Now, the way we want to protect this is by introducing a concept or a technology called confidential computing, which is not about encrypting data at rest or in transit, but it is about protecting data when it is in use. So let me clarify this really well. Data encrypted at rest or in transit, we already have it for several years. SQL Server, BitTorrent, yes, or HTTPS. Everything is encrypted at rest or in transit. Safe story there. But think for a moment. When your data or when your application is accessing your data and load this data in memory, in a server, in a virtual machine, if there is an intrusion to that virtual machine and someone takes a memory dump of that application that is running inside the virtual machine, they can see all the clear text. So to prevent this, confidential computing isolate the memory space where your data and your code, so also your machine learning code is running, inside a region of memory that is called a trusted execution environment or enclave, completely isolated, and the access to this enclave, to this memory space, is protected by hardware encryption. This hardware encryption is done at CPU level, so the CPU has some unique extension that are called SGX, software guard extension, based on Intel technology, and they protect the access to this memory space. So this regional memory is not even encrypted. It's like it doesn't exist. And this is the screenshot that I shows WinDebug, which is an application for memory debugging that is trying to look into SQL Server running inside this enclave. And I don't see scrambled data like you will see typically if the data was encrypted. I actually don't see that at all. I don't see this memory space. It's completely isolated. It's completely a black box. It's not addressable by any application that is not authorized to access this attestation, this enclave, using an attestation service. So SQL Server is an application that has been optimized to run inside the enclave. Let me show you this in action. Now, this is SQL Server Studio, and I have a table of employees with two encrypted columns: SSN, Social Security Number, and salary. Two confidential pieces of information. I'm encrypting a rest. Nothing new in here. This is encryption of two columns in a table in a database at rest. Something that SQL Server have been doing for years and years now. So now I have an ASP.NET application that shows the list of all the employees. Every time I run this page, I'm running a SQL query. Now, what's the problem here? The problem is that the SQL query has some parameters for salary, range, or search by social security number. So the where condition of my SQL query can be profiled, and it can reveal confidential information in the query itself. So a SQL profiler like this can intercept this query, and if this query was in clear, I would see the indication of salary and indication of SSN, which is a confidential information. I don't want to give it away. Instead, by running SQL Server in the enclave, I can protect with a search pattern that is completely encrypted, and not even the DBA, not even the database administrator can see. Only SQL Server process knows how to decrypt this data and turn this encrypted information into the actual value for SSN or salary, and return data from the database itself. So at the end, this is the concept that is at the foundation of creating a multi-party machine learning process where multiple parties share their data to a central enclave, to this memory space where the information is completely protected by anybody else. Each bank, in this case a bank, obtains a key from an independent attestation service. The attestation service recognizes that these banks are authorized to transfer data into the enclave, but they also know, the attestation service also know that these banks cannot take data out of the enclave. Who can take data in? Who can read data? Only machine learning. So the attestation service create a trust between the machine learning service running inside the enclave and the different data sets that are stored inside the enclave itself. In this case, machine learning service can benefit of the aggregated data sources, of the aggregated data set combined into a larger data set. And as you know, machine learning works better the larger the data set and the increased accuracy of prediction. So the result will be better because we are aggregating together different data sets from different sources without revealing these data outside of the enclave itself. This approach is completely confidential, but has a little disadvantage, which requires data to be shared from the bank with the enclave. And although this data can be protected with the relevant encryption and running inside the enclave is not exposed to anybody else, the limitation is that some institutes, especially financial institutes, don't feel really comfortable of sharing their data outside, even if it is inside an enclave, which, as we have seen, is a completely isolated black box. So what they do is, or what they prefer to do, is to take a decentralized approach called federated learning, where instead of the traditional approach on the left-hand side, the centralized learning, instead of sharing their data with a centralized machine learning training infrastructure, they take the FL, the federated learning approach, where they maintain, they keep the training or the model, the machine learning model at home, on premises, running in their own infrastructure or in their private cloud, and then they only share the trained model. So they don't share the data source any longer, they only share the trained model. Inside the inside the federated learning aggregator, which is a centralized server that collects all the trained models, not the data source, only the trained models, an aggregated, a global model is produced, which is then used for generating the scoring, the prediction of the machine learning service. Now, there is still a risk with this approach. The approach is that these trained models, although they don't contain the original data source, because it only contains the training part of it, they can be poisoned, which means that fake data can be added to these models, or can be even reverse engineered to go back to the training data that has been used to generate the model, especially if the data has not been anonymized. So there is still a risk in using a federated learning, which confidential computing resolves by adding this extra level of protection, which is the enclave. So the aggregator that we have seen in the previous screen, which aggregates the different trained models, can run or will run inside an enclave, a confidential environment, which is isolated from everybody else. In this case, it will protect also your trained model, which contains the algorithm used for your machine learning service, which very likely is your proprietary IP, your intellectual property. So you don't want to share it or take a risk that this is reverse engineer and then you lose access to data and also to your know-how. So confidential computing will protect in this way. And the way it works basically is by running this inference service inside the SGX enclave, not the Intel SGX enclave. In Azure, we have an Onyx inference server, which is completely confidential. Onyx is one of the different formats that exist for sharing trained models. So you don't share the data set, you share the trained model. This trained model is formatted according to the Onyx interface and shared inside a a protected memory space, which is the inference enclave. This runs on Intel SGX technology, which protect the access from anybody else. All right, so let me see if there are any questions on this before sharing more information. Um,
Apparently, no questions, Stefano.
Not for
It's
now.
all good
That's
so
okay.
far. I
So
actually have I actually have a question for you if you want,
yeah,
but maybe I can share it in the at the end. Maybe it's better, right?
sure. Look, this is the last slide. Some URLs, some references for everybody to get started with Azure Confidential Computing, with
Mhm.
the Intel Open Federated Learning Frameworks, with the Confidential Onyx, and these are all open source. It's all on GitHub. If you want to get in touch directly with me or with the Confidential Computing product group at Microsoft, the URL at the bottom is a form to fill in so you can get more information around confidential computing, or just get in touch directly with me over LinkedIn or via email. Happy to get more answers or to support your journey to confidential computing, which is not just for financial machine learning, as we have seen, but there are several use cases where you want to protect your data from sharing with other parties and even sharing with the cloud provider. So even the cloud provider in this case cannot access data that is running inside the enclave. So that's all for now. Thank you very much. Questions? Yes.
Great session, Stefano. Thank you so much. Well, so far it looks like we don't have any question from the audience, but I actually have a question for you. As you know, that definitely machine learning is having some investments in terms of the democratization of this technology to enable even people outside of the data science and the machine learning area to build their own machine learning solutions. So I wonder, typically, imagine if I have the need to build a machine learning solution, right? And knowing that I have, as an example, the automated machine learning available, that I can use my data and build automatically my machine learning solution. The question is, how do you decide where to go in terms of building your own custom model, machine learning model, or building your machine learning solution using automated ML or similar feature?
There are different. So if I understand your question well, is the different approaches that you can take are based on the kind of problem that you're trying to resolve. Is a regression
Mhm.
problem? Is a classification problem? Is an anomaly detection? And this has an influence of the kind of frameworks that you will use. PyTorch or TensorFlow are very popular ones, but there are some other ones, and I actually showed Azure Machine Learning Studio, which is a completely visual approach with no coding required. There is an opportunity to add some Python coding if really needed. Otherwise,
Mhm.
you would be able to take a completely visual approach. And then there is a problem also of storing your data. So where you are, where are you sourcing your data set from? and the anonymization part of it, because again, one of the risks of doing machine learning at scale is that your machine learning algorithm may contains or may reveal confidential information which can be used for accessing obviously data that you don't want to share. So there are a number of elements to take into consideration, and the starting point in general, if you consider doing machine learning for the first time, is try to identify your the problem that you are resolving, and then approach these with gradually, as in load the data, train the data, score the data, and do the evaluation. This is, if you follow these 4 steps, typically you will end up with something that is robust enough to do some basic machine learning. Then obviously there are always a lot of optimization that can be done that will probably require a little bit of understanding of how machine learning works. But in general, and I'm not a data scientist, for example, I just learned to do this by myself. I took this approach of starting step by step, and this is why Machine Learning Studio, which I'm gonna put it one more time here on screen, will help you a lot with this, because Machine Learning Studio will really help you getting started. So if you create a new service, you can start from a blank experiment if you know what to do, or you can take one of the many that are available in the gallery, and then learn how these experiments have been done, and maybe even modify an existing one and trying to personalize with your own data or with the output that you expect to do.
Yeah, amazing. It's clear. Out of curiosity, by the way, that studio that you are using, is it the classic studio or the new studio?
Yes, this is the classic one, which is available at this URL studio.azureml.net. There is a new version which runs inside the Azure portal, and is a bit more flexible in terms of the resources that you can deploy, and integration with Azure DevOps from a pipeline, so a DevOps perspective. But I like the classic one for development, because you don't have to worry about the infrastructure that you're deploying. It just when you publish a web service, it's just there, ready to be used as a REST API. The new experience is you decide also the container cluster where you want to deploy, which is more flexible in some way, because it gives you the possibility to choose the power that you want to allocate, which has an influence obviously on the performance, on the speed, but it comes with a cost, right? So you need to provision a cluster, which is a cluster of containers on AKS, Azure Kubernetes Services. You want to integrate with Azure DevOps pipeline for deployment automation. A little bit more complex. So depending on how experienced you are in the process, classic is the get started for beginners like me, and the new experience in Azure portal is the more advanced, where we have a full control on the infrastructure and the automation.
Amazing. And we have here some comments, so people are definitely enjoying your session, but so far we don't have any questions apparently. I just take the opportunity as well to just share quickly with you, all the attendees. Please, if you want now, register to this session so you can have a chance to confirm your attendance, and also have chance to win great prizes, including Microsoft Swag Kits and C# Corner Swag Kits. And I'm going to share in the chat as well with you the link. So given that, I don't know, Stefano, do you want to share anything else with the audience?
Yeah, I will share the links to the resources because some people may have been able to take a screenshot, but probably not everybody. So what I'm gonna do is I share this in the comment, so it's easier to access. Can I do that, or I can, or I should
Yes, can you share your screen again so I can activate them?
yeah, sure. So 1 second that I go in presentation mode, share the screen.
And again, for the ones attending this session, by registering to the session, at the same time, you are able to provide feedback as well to Stefan, showing how great the session was. Okay, so you can leave
Yes,
some comments. Yes, I have your screen. Yeah.
okay,
Yeah, it's sharing your screen already. Yeah.
perfect. Okay, so that's it. Thanks very much. Thanks for attending, and stay in touch.
Thank you so much, everyone. And just to let you know, okay, we are going to drop this track here in Twitter for a quick pause because we are going to deliver now some content for the in Chinese for the Chinese audience. But you also have running in parallel. You have the YouTube channel and you have the Twitch channel. So please go to our websites. I'm going to share the link with you, and from there you should be able to navigate to the different channels. Okay. Okay, the link is sent. So, and once again, thank you so much, Stefano. Amazing session, and thank you so much for your contribution, and thank you everyone
Thank
for
you.
attending. Wish you a good day. Thank you.
Bye.
Bye bye.